Our Sun and Solar System began as a dense cloud of gas. Over time this cloud begins to condense under the influence of gravity. As the cloud condensed further, nuclear reactions start and a star is born. As the young star starts burning, leftover gas around the star may start clumping together to form planets. The star will then keep burning hydrogen to form helium for many billions of years. For a star such as our Sun, this can go on for about 10 billion years. After 10 billion years, all the hydrogen has been converted into helium. The core of the star collapses, while the star's atmosphere expands and cools. The star becomes a red giant. A red giant has a high luminosity. However, it has a surface temperature of around 3000 degrees Kelvin. It also expands to about 100 times the diameter of our Sun. After time, the star will eventually start ejecting gas from its outer atmosphere. This ends up exposing the core of the star. After the outer layers have been ejected, the core remains as a white dwarf. A white dwarf is near the end of its life. It has the same mass as our Sun, within a volume the same as Earth. The matter is very dense. One matchbox clump of matter weighs 1 ton. The star consists of nuclei and electrons compressed into the smallest volume allowed by quantum mechanics. The white dwarf will eventually cool and become a dark star. There is an upper limit on the mass of stars which can follow this path. Stars 1.4 times the size of our Sun will have a more violent life. They will burn their atomic fuel much faster and will eventually explode in a supernova. These stars are all powered by the same process. Powerful nuclear reactions that release much energy. Stars are giant factories that take atomic nuclei and convert them into more complex nuclei. The most simple nuclear reaction converts helium nuclei, protons, into helium nuclei. Other reactions in the core of stars led to the formation of elements such as carbon, nitrogen, and oxygen. There are also byproducts of these reactions, namely alpha particles, beta particles and gamma rays.